Send him there. Right, everyone. First of all, I'm gonna jump straight in. So first of all, thank you everyone for coming. It's a nice small group we have over here, but this is more than an experiment, really. I wanted as Code Club, I wanted us to start doing more work with adults, and one thing that used to happen in the BCS used to happen in other places were monthly talks. So I'm trying to set up a sequence of monthly talks, and this is the first one, the inaugural monthly talk. Hopefully, we'll grow this from this state. You notice that the dates are aligned with GDG's talks. So they're every 2 weeks, there's either a GDG talk or a Code Club talk. So there's always opportunities to meet up. This is our Code Club space. We meet here every Saturday between 4 and 6. If you guys aren't doing anything and want to come meet other people who are like-minded, we do more work with kids in that particular space, particular slot. But it's an amazing, thing to see kids come to grips with coding, come to grips with robotics, come to grips with stuff that excites them. We're all kind of here because this stuff excites us. It's a sunny day outside, and we're all here listening to me. Being able to instill that passion into others is actually quite rewarding. So that's why we've got all that kit kind of in there. The topic for today is data lakes and big data. This sparked out of a conversation Steve Wilson, one of our volunteers, and myself had, where he's very much into. I got to know Steve 25 years ago, SQL Server 6.0 and 6.5 days. And we were talking about data warehouses and data lakes. What's the difference? How did we get here? And that's what's kind of sparked this talk. It's an introduction into big data, introduction into data lakes, bit of mention into some of the challenges, and moving into medallion architecture, which is one way that a lot of organizations choose to implement their data lakes. And then finishing off, I want to show you Databricks. Azure if you have an Azure subscription, you can get yourself a 14-day trial of Databricks, so everyone can have a play with that.
Mm-hmm. Is there one that you get a subscription using Revolut? How do you get one, or do you use your regular bank account?
I'm not sure which bank account I use, but I'll check and I'll get back to you.
There's a company that's up in that hill up there on the workspace up there.
Yep.
Prospect Hill, and they will set one up for you, like you pay them. Just going to be any else.
I think I use an HSBC credit card for mine.
Okay.
I'll see if. Anyway, I'll see if I can walk you through that later.
Yeah, no, that's fine. I look at the HSBC as well. I just hate using my regular bank account with cloud services.
Yeah.
Just in case.
Right. Let's switch back to data. The first thing I want to talk about is, we've all seen slides like this. The amount of data that's being generated in the world is growing exponentially. Every year it's bigger than others. This is a slide from 2019 with some figures. But you're all people in technology spaces, so I don't need to convince you that data is forever growing. And with data comes the need to store, to manage, to organize. And if you look at most organizations nowadays, they all generate a lot of data. And a lot of management theory is around turning organization to use evidence-based decisions. That evidence comes from data. That gets fed down through what the organization does, but then gets fed up to the top layers of the organization to make their choices, to make their assumptions, their hypotheses, their experiments. Without being able to manage that data, without being able to generate meaning and knowledge out of it, then that data is useless. This talk is one to talk a little bit about data. When many of us started in technology, we've all worked with relational databases. We probably started database at university, and you might remember E.F. Codd was the guy who came up with the idea behind set theory and relational databases and SQL. That was 1970, just to make you guys feel a little bit old. So we're not going to talk about SQL, we're not going to talk about Oracle, we're not going to talk about DB2. But the idea behind relational database was very much around structured data, putting data into a format that we understood and that we managed. And if it didn't fit in that structure, we made it fit. Otherwise, the tools that we have didn't work in that particular space. Okay, so the focus was very much on structured tabular data. Schemas we used were defined upfront. We knew what they were, and we squeezed our data into them, and very well suited for a lot of business applications. Business applications are mostly transaction driven, and that lends itself quite nicely into those models, which is why structured databases were with us for a very long time and will remain with us for a very long time. The challenge came when we started to look at other types of data. So what about unstructured? What about semi-structured data? And I found this picture online that claims that 80% of enterprise data is unstructured. I don't know if that's true or not, but I thought it would be a nice figure to put in front of you. When you think, however, about what happens day to day in our organization, and you start looking at voice calls, a lot of companies have call centers and collect data in that way. Making sense of the data is quite important. If you look at video data and how much larger it is than relational data, that kind of fits into that space also. Again, on the other side over here, we've got some definitions of unstructured and semi-structured data, just for you to have a look at. As people became more conversant with this data, a new term emerged. You might have heard of the word big data. Big data is categorized around having large amounts of volume, first of all, large amounts of velocity, fast-changing data, large amounts of variety within the data. But there's also something that the last V over there on the 4 Vs, veracity, is something that we kind of need to get our head around. Because when you think about relational databases, most of the time, the data that we have in those databases represents a source of the truth. Well, veracity refers to the fact that sometimes when we collect data within an organization, the quality of that data isn't what we want it to be. And sometimes we don't even know if that data is true or not. Okay, all you have to do is listen to what Trump is saying, and capturing that in some sort of structure, and then realize that 2 days later he was referring to something completely different, and our assumption of the truth was wrong. Okay, if you look at social media data, people will claim stuff there. Okay, so it's not just the structure of the data, but it's also the value of the data that you're collecting over there. Interestingly, the 4 Vs were the textbook definition of big data. There's a 7V definition also, which includes value, variability, and visualization to that kind of data. But I'm not going to go into more details on those. At any point, if anyone has any questions or you disagree with me, please jump in. We're a small enough group that we can turn this into a bit of a conversation. But I kind of wanted to set those as a focus on data lakes, why data lakes emerged and where they came from. The idea of a data lake is a centralized repository designed to store huge amounts of data in their raw format, in their native format. So if something's captured in an organization as a relational database, that's fine. If something is captured as semi-structured data in JSON, it can handle it. If something's structured as audio, video, a data lake can store that information also and process that information also. Okay, so it's referred to as a technology that lets us pull in data into one central place so we can do something about it. We can do something with it. One interesting idea is the idea of schema on read as opposed to traditional databases, which are schema on write. What that refers to is when we write something into a relational database, the schema is defined for us. It's fixed. It's there. We can only put data into it if it conforms to that schema. Otherwise, that entry into the database gets rejected. Data lakes work on a completely different basis. They'll take data in any form it is, and the schema is defined at the point where you want to use that data. Now, the implication of that is actually quite far-reaching, because one of the bigger problems with relational databases and BI data warehouses is that if we build our structure, fill it up with data, start producing business value, and somebody comes up with a new definition of what that value is or what they want to use that data from, we usually would have thrown that source data away because we've aggregated it into a data warehouse. and we don't tend to hold on to that data once it's been processed. While with data lakes, if we have that raw definition of that data, we can process it in a variety of ways. And if someone comes up with a new way of looking at that data, with new questions that need to be asked, we have the original source data. Now, the biggest thing that comes in your mind when you think about that is, isn't that going to take a lot of space? Isn't that going to take a lot of size? And the answer is yes. One of the things that enables data lakes is the availability of cheap, humongous spaces for data. Okay, so the technologies underneath them are designed to scale to a massive amount. Okay, and that is almost a given when you talk about data lakes. Obviously, there's a cost implication to that, but the cloud providers have a special tier of data of storage that's actually the cheapest they have, which is in the case of Azure, it's ADLS, the Azure Data Lake storage is very cheap compared to other storage mechanisms that they have. Any question? Okay. The key is that flexibility I mentioned before. Okay, so that's okay. Yeah.
My question is this: until now, we took the data, processed, took what we needed, and disposed the rest.
So when I say until now, I meant until the emergence of data lakes, which is around 10, 50 years old.
Holding on to this data doesn't bring issues, for example, with data protection.
Yes.
Where you have to keep them for as long as you need. If you're coming 2 years later, should the data still...
So again, one of the challenges with data, and this is not a technology challenge, it's a regulatory challenge, really, is what type of data are you storing? What's your retention policy around it? Are you cleaning up the stuff that you need to clean up? But these technologies provide the capability for that. Okay. So if I had to use an example that's not going to get me into GDPR for now, let's say we've got sensors all around the Isle of Man that are tracking all the cars that are moving around, which are anonymized, that you're keeping for measuring, I don't know, pollution in the air. For example, you can keep that data forever because it's not tied to an individual. Just as an example, there are those particular types of data sets.
Yeah, but you have to clarify the purpose. You have to collect data for a
Yes.
purpose.
Yes.
If you're using them for another purpose, then you are in breach.
Yes. Yeah, no, all that stuff needs to be taught about. And in fact, the whole data is now becoming a discipline in its own. And part of that is this evolution and maturity through this technology, because as the tools become more powerful and what people can do with them more powerful, then the whole regulatory side needs to catch up with that to make sure we're doing things in the right way. And in fact, one of the things I'll mention later, I've got a slide about the evolution of data lakes, is that whole governance aspect that almost didn't really exist in the beginning, which resulted in people creating what are called data swamps, which are big collections of data that they can't use, that they can't manage, that they don't know where they're coming from. So the whole governance around data is a very important topic, which we'll just touch on today, but we could probably do a whole talk about. Andrew?
No, I was just going to say that a lot of times you'll take a large set and you'll aggregate down into different granularities and anonymize at that point as well. So storing smaller sets that you go back in time, which are anonymized, which is, you'll be able to go zooming into the detail anymore, but that's quite common.
So yeah, anonymization is one of the techniques, for example, for keeping data forever.
Personally identifiable information as well is a nice technique, because that doesn't matter if you throw it into the data lake and if you're using a different key for each PII.
It depends on what you're using for. And again, yeah, there's different strategies for that kind of thing. But for example, I work for a company called Canada Life that provides financial products. You could buy a product at the age of 20, which will live with you for your whole lifetime. And you need to keep that data because it's part of a service you're offering, if you know what I mean. So the retention there is very long. It's the lifetime of an individual, for example. So these are different cases, and this is meant as a generic talk, really, about the capabilities of the technology. Key point over there, how data lakes are different to data warehouses. And the main point over there is that with data warehouses, data is all processed and organized into a schema before being put in a warehouse And they use multidimensional schemas. They use star schemas, snowflake schemas to be able to slice and dice the data in different ways. But the key point is that that schema is defined before you start putting any data into there. So if you want to come up with a new schema, you almost need to start collecting data all over again. Okay, analysis is done on the cleansed data. While with a data lake, raw and unstructured data goes in the lake, and then data selected and organized when it's needed. So it's a different mindset, really, to what we're talking about over there.
Yeah, I work with a product called AWS Athena, which is an interesting hybrid of these notions, because you're just storing data in S3, which is like object storage, you know. You can store it in various formats like JSON, CSV, or another format called Parquet, which is
Parquet is a native data lake kind of construct.
But you can throw anything you want into that S3, and then you have a schema that you apply. I believe in Azure, there's an equivalent which is called Purview, and Athena, the AWS is called Glue. And that's a schema that you say, this is the shape of the data that's in there, and you can select from all that stuff. You can also transform the data and put it back into the data lake and apply a schema to where it's going. And so you kind of blurs the lines a little bit, you know?
Yeah. And we'll talk about those when we get to the Databricks data lake kind of thing, because those are all capabilities that we have. No, it's fine. That's a nice thing about being a small group, is that we can kind of have a conversation. I wanted to show you over here some of the evolutionary part that data lakes came about, because I remember building a course for a university around 10 years ago on data lakes, and this was the definition of data lake. There was a product called Hadoop. Everyone used Hadoop, put data into Hadoop, and Hadoop had this capability called map and reduce, which could scale and do things in parallel across your data. And everyone went, great, we can do a whole bunch of new things with this new technology. There were problems with that. And the biggest problem is something I'm going to talk about in a bit, which is something called a data swamp. Just because you can stick all your data into one place and then figure out what to do with it later, doesn't mean you shouldn't think about what data you have, you know, what your retention policies are, what you're going to be using it for, how we cleanse it. Excellent. Yeah. I'll do data swamps and then we'll go and grab some pizza. But let me run through this, because I found this actually quite interesting. First generation of data lakes in 2010 onwards to 2014 was really Hadoop based. And this is where the challenges started emerging. You know, the tools for metadata management, for governance, weren't around at the time. So people tried coming up with manual methods of doing it once they realized what the problem was. But a lot of money was spent on data lakes in that particular period, which didn't really give the business benefit that we kind of needed. Cloud started coming in over there, and tools started becoming available on the tools. Interestingly, over here, you'll see Hadoop, MapReduce, Hive, and Pig. A lot of these were open source Apache-based tools that were pushed into that space. What came about in this period was a new tool called Spark. Spark is an in-memory database that does all the processing similar to what Hadoop used to do, but does it much quicker. And because it's in memory, you can do a lot more with your data. 2019 to 21, we saw products coming around referred to as data lake. This was really the point where organizations started using these data lakes in anger. And I remember the company I was working with was using something by a company called Cloudera. Not sure whether they were bought out by someone else, but I haven't heard from them recently. But the focus over there was the focus on transactional integrity, schema enforcement, and support for the business intelligence that's being used. Nowadays, we call them intelligent data lakes. We've got the tools to govern. We've got the tools to catalog and secure these databases, which, as we're, with PII is kind of becoming more prevalent in people's mind, because before GDPR, we used to store personal data, but people didn't really used to care about it. Now there is a legal reason to care about it. So you need the tools to mask data, you need the tools to obfuscate data, you need the tools to anonymize data. Again, streaming services kind of come into it at this point to be able to ingest streaming information and process them in real time. And people are talking about more concepts of data mesh and data fabric. We'll talk about these in a little bit when we talk about definitions of data lakes. So this was quite interesting because I did a bit of data lakey stuff over here and then I stopped. And then when I came back and turned my head, it's like the whole thing just really progressed to a point where it's very mature now and available to anyone really with the tools. Before we stop for pizza, I just want to talk about data swamps, which are a real thing. The problem was when the initial data lakes came about, the capability for cataloging, putting metadata around your data and governing your data was very poor. Organizations who put stuff in place put stuff through manual methods rather than because the tools let them do. So you'd still have the idea that an administrator would still have full access to all the data. While nowadays that has kind of moved on, there's this concept of having a data plane and a control plane, and the permissions you put on your data plane are very different to what your control plane has. So an administrator can create a database, but may not have access to the data that are in there, which was alien back in the day. The problem with that, the data was difficult to discover and trust, knowing that the data you have is high quality or not. Storage costs, if you're storing data and you don't know that you already have a data set that represents exactly the same thing, you're going to keep storing it over and over again. And it stopped the adoption of these technologies being used in anger, really. My next few slides talk about the modern data ecosystem. I'm just going to talk about the 6 important factors that tie into this. But you guys want to grab a slice of pizza before? Oh, hope you enjoyed the pizza. It was courtesy of Flutter, who are sponsoring this series of talks. And hopefully we'll see you at the next ones. There'll be more pizza at that also. Okay, I just want to run through, I've got 6 slides over here which define what we mean today by a modern data ecosystem. And what was interesting putting these together is if I put these together a couple of years ago that have been different, and a couple of years before that have been different also. So this is today's interpretation of what a modern data ecosystem is. First of all, it's cloud driven, it's cloud native. And that's kind of easy to understand, right? Because if we're talking massive scales of data, being able to host them on-prem is going to be quite hard, while cloud gives you the ability to scale any which way you want, gives you the resilience that we've kind of learned to expect from cloud infrastructure, and also global accessibility, which is very hard to do on your own without cloud. Auto-scaling and serverless compute is something that these platforms use. Databricks is actually quite fascinating because it spins up as many Spark clusters as you tell it to on the fly, runs them for a short amount of time, then turns them back off again, which gave our infrastructure guys a bit of a headache because they were trying to understand. They tried applying the on-prem mechanism of let's understand what boxes we have and what their lifetime is. And when you talk to them about on availability kind of clusters, they kind of go, how do I manage that? Well, the answer is you don't. The platform manages that for you. I mentioned before the idea behind data mesh and data fabric. Just going to drill into these a bit just to explain what I mean by them. Data mesh refers to the idea that data within an organization has different owners throughout the organization. So if you think about it, the accounts team manage their finance data. But if you've got a product team, you've got a customer management team, they have their own data sets that really they're custodians for. This has led to the idea that data is a product within an organization, and different teams will broker this product to each other to enable what their local goals are, but it needs orchestration for the organization to drive that organizational benefit for. The challenge over there is that some organizations have gone down the route of having data silos where people own their data and don't want to share it. But really, when you tried, what this is moving away from is when data lake started, the idea of having a data team that managed all the organization's data came around. The problem with a data team is they treat all data the same, but the process of collecting the data and curating the data and making sure that data is high quality is actually something that the individual owners of the data are probably best suited for within an organization. There's a concept in there within data mesh of self-service data infrastructure also, that data is published with an organization. There's a catalog for data and different users can reach in and pick out which data they want. Again, which is very different to having a data team who's managing that for you. There's that kind of federation within the organization. In order to make that work, you need proper governance around that data. So data needs to be of a certain quality before it gets accepted into a central catalog. Data needs to be maintained. Data needs to be timely. Data needs to be clean. Those concepts aren't just something for the data team. Those concepts are something that need to be adopted by everyone in the organization who's producing the data as part of their day job. If you think about it, if you go to Marks and Spencer's and buy something, probably a bad example. What I mean is that purchase of something is a transaction. But before that transaction, you've also had contact with a member of staff, for example. If you can capture that, if you can quantify that, don't worry, then that is valuable to the organization because it helps them understand how their customers behave in store, and that behavioral analysis is something more behind the transaction that can help you improve your business. Now, the person doing that transaction is somebody who, any member of staff. Do they record that? Do we have technology in place to record that for us? These are all different questions that the idea behind data meshes kind of bring about. Data fabric refers to the technology behind this, the ability to have the tools to be able to integrate the data together. Okay, we're talking about unified data access, being able to access our data from wherever within the organization, having a single integrated layer, intelligence around our data, a method-driven approach, real-time and batch integration, and driving that federated governance before, the idea of self-service and end-to-end governance. So where the data is created all the way to where it's moved. So what's interesting now is we're seeing data emerging as a topic. So you can actually go to university and do a course about data management, data science, which ties in all these different governance. So data scientist is probably one of the most growing kind of role in the space. And these aren't technology people, these are data people. Which is interesting because data always used to be the provenance of techies, right? Yes, yeah. That's where those disciplines come from, right? One thing that we expect to find in a modern data ecosystem is the idea of self-service analytics. We have the tools nowadays with Power BI, with Tableau, for business users to ask questions. Now, in the past, we needed a business analyst behind that who would break down the data, go to find what sources are needed to justify that particular query, the resources tied to that. But because we've got technologies available now that can analyze a prompt and go off and find what sources of data are needed for that, we're seeing a lot more intelligence in the platform, which is enabling that self-service to happen. And that's something that's really fascinating in Databricks also. It's got a tool where you give it a whole chunk of data. You might give it, a whole relational database, and the user can ask a natural language question, and it goes off, figures out what data it needs to answer that question, and generates visualizations for you based on that question. So this is expected today in today's ecosystem. In order to enable all this, metadata management, capture and catalog of our data is really, really important. And what we see, you mentioned Glue before, each of the different cloud platforms has their own kind of variety of doing that. Integration with AI and machine learning is something that's expected nowadays. And again, you can see the different technologies over there that are available on all these platforms. And finally, we expect security and governance to be part of the platform also. So, as I said, this is not just a technology piece. It's not just what can we do with the data. It's also what should we do with the data. And part of that is regulation. Part of that is legal requirement. Florida mentioned GDPR right up at the front. And it's interesting to see these tools. And for example, Databricks has it, I'm sure other platforms have it also, is the concept of data masking, where the data is stored natively in the raw format. You've got the data in there. But when somebody is accessing that data, each row is analyzed to see what the rights of that user are against what the data has. And if they don't match up, the data is shown, but it's masked. So you can't actually see that data. So that is a layer above the actual data storage that's doing that governance for you before making that data available to somebody. So as an administrator, I could not see that data if I don't have the access for it. I know it's there. I'm seeing a masked version of it, but it's only the people with the right access who can do that. And again, coming from SQL Server and Access and FoxPro and all those things, this is like magic to me. But it's built in, it's baked into the tools now, which means that it makes our jobs as technologists much easier. It does mean that the organization needs to understand what data it has, what rules it has around it. And that's where we're seeing roles within an organization around these governance. There's an idea of data stewardship that's kind of coming out with these data lakes, is that somebody's responsible, somebody is an owner for this data. He's the person who defines who can see that data. He's the one who's legally responsible if the data gets leaked. Again, not a technology role, very much a data governance role. Any questions around those 6? I kind of wanted to just pull them out as pillars. The next thing I'm going to talk about is a typical architecture that we tend to use with data lakes. And this is what's called the medallion architecture. It's called medallion because data is split into different tiers, a bronze, a silver, and a gold. And the typical definition of those is that the bronze layer contains all the raw data we've collected. Okay, so data coming from everywhere in the format that it was collected. Okay, whether those came from a CSV file, whether those were purchased, and the technology that supports that also, there's something within database called, within traditional databases, SQL, Oracle, etc., called change data capture, CDC. What CDC does is a copy of the database is stored in the raw layer of my data lake. But as soon as there's a change on any of the elements in the database, a row has changed, a table has changed, a table structure has changed, that's replicated straight into the raw layer. So as soon as a new record is entered, it gets updated in the raw layer. So it's a real-time update of data in our source database. That's change data capture. It's a lovely concept, very hard to implement. Because yes, in SQL Server, for example, it's a plugin that you add in. Sorry?
It's an expensive change.
It needs to keep track of everything in there. So you know how SQL writes logs of what's happening. It's not just log shipping, it's everything else that goes around that also. So CDC, look out for that.
Does it keep the record of the original data?
So,
Does it keep both?
so within the data lake, yes, it keeps track of every change to that particular data set. I'll use the word when I come to Databricks. Databricks implements a technology called Delta Lakes. Okay, have you ever heard the word Delta Lake? It's a data lake where every data item is audited and tracked, so that when a new record is added to a database, there's a new version of the database with the new record. When a record is deleted, there's a track of that. So at any point, I can go back in time to how that was at a particular point in time. So the source databases don't implement that because it's very expensive to track. You need to keep storage of everything, but Delta Lakes do that natively, which is fascinating.
There's one database, Crouch DB, there's that underneath covered,
Mhm.
built on a key value store underneath, but that's
Yeah.
the only one.
Mhm.
There's some stuff in SQL 2011, you're a SQL guy, maybe you've heard of it, but temporality or bitemporality, Yeah, you never touched
I never
about
used it though. I've never used it. I read about it. It was there, but
I've heard about it, read about it, but I just
the thing is that data lakes do this natively with any data set that they have. Okay, so whether it's CSV. The other things that data lakes do, because we're talking about putting relational data into data lakes, they also have connectors for streaming data also. So if you've got those changes coming in over Kafka, for example, they'll integrate straight into your data lake. So if you've got IoT devices generating or social media generating events, that data gets streamed straight into that raw layer. As you can imagine, that raw layer can be quite chaotic because there's a lot of data in there. It still has to be cataloged, there's still metadata around it. But for the business to actually use it, that's still in its raw form. Okay, so that's where the next layer comes in, the silver layer. And this is typically, normally what we do is we implement data pipelines that take that raw data and convert it into something that makes more sense. Whether that is cleansing it, whether that's amalgamating it with other data sets, for example, so that we can actually start sanitizing the data and standardizing the data for the organization. So that standardization layer happens within the silver layer over here. Okay, so that might be, for example, I don't know, I've captured information about a client, but I'm not sure whether his address is right or not. So there might be a process in the silver layer that checks it against Experian data and then flags it that, yes, I can elevate this, the credibility of this data because I've verified that data exists somewhere else, for example. So you've got that cross-checking. That layer, that level, that silver data then gets promoted to a gold layer, which is where our Power BI and our business users consume their data from. Okay, so there is a transition, there's a pipeline of steps over here where the data is cleansed, sanitized, and converted into business terminology so that the business then can run their own reports against that data. So the data isn't run straight against bronze. We kind of have this idea of promoting our data through various layers. And data lakes have data pipelines, these capabilities, to process this data as it moves from one layer to another. Okay, just to add a bit more to the techies in the room, here's an example. So I might have my bronze layer is pulling in data from cloud storage, from Kafka, from Salesforce. I've got my customer, my transaction, my accounts, my opportunities, my leads are being cleaned in. Within the silver layer, we make sense of those. And whether that's amalgamating data together, whether it's cleaning them to make sure that all the data, all the fields that I need for my reporting is correct. So that then gets promoted as a data set in my goal as customer spending, account performance, and sales pipeline, for example. So the business owners don't, the reporting users at the other end don't really care where that data is coming from. What they care is that data is being sanitized and conformed to the standards that they want before they can run reports against it. That's an example of a medallion.
it can even be like, it doesn't even have to be like somebody fancy or whatever. You know, the gold stuff, you can just be.
You can hook up Power BI to it.
Well, or even like sometimes, you know, just aggregating it into like a JSON blob that you're going to throw down into an analytics dashboard, you know, but it's highly processed.
Yeah. And again, this is just one type of way of handling it, right? Because it depends on the type of data you have and what work you need to do on it, you know. But yeah. Okay, what I wanted to do next was show you a bit of Databricks. We just wanted to point out, if you've got an Azure subscription, there's a 14-day trial offering over there, which means anyone can just pop in and have a play. Now, just to put all my cards on the table, I'm not a Databricks expert. I spent some time playing with it this afternoon and went, oh, it can do this, oh, it can do that. But you know, it's something to play with. I've become more of a theory guy than a practical guy, I'm afraid. So let us switch this to, I also learned how to switch my screen from screen mirroring, from extending to screen mirroring without having to unplug and plug it back in again. So let's do that. There we go. Okay. So I just want to show you, first of all, how to set yourself up on Databricks. Hopefully this is remembered my context. Yeah, so pop into Azure Databricks. If you want to create yourself a new service, click on Create. Just wanted to show you over here, pricing is a trial over there. All you have to do is assign a resource group to it, choose trial, and it goes off and creates the whole environment for you. The other thing I wanted to show you was Databricks themselves have a Databricks Academy, which has courses and training for anyone who wants to learn a bit more about Databricks. What I did earlier was I set up a Databricks workspace, and the workspace comes populated with some sample data also. So this is a Databricks workspace over here. I'm just going to show you some of the data I have in there. If I go to catalog, if I look in samples, these come out of the box with the trial. I've got a table called NYC Taxi that has a set of trips in there. And this is how Databricks looks at its data. It's showing you the attributes over there, the columns. This is some sample data from there. More details over there, permissions, and the history on the database. But it's not on there. So this is what the data set looks like. Out of the box also, the sample has a dashboard on this data. So I'll just show you what that dashboard looks like. So this is a dashboard built, needs to wake up, sorry. This is a dashboard that comes out of the box with that sample data. So behind each of the different blocks of my dashboard, it's just SQL sitting behind that. But Databricks can natively run SQL, Python, R, and a range of other languages also. Behind the scenes, it converts everything to PySpark and runs it on a Spark cluster that it instantiates when it needs. You might not notice there was a bit of a delay there when I started. That was my Spark cluster coming up. The Spark cluster I have behind the scene, that's my starter over here. Can I see what's in it? Maybe I'll show you maybe somewhere else. But behind the scenes, each of these blocks is just a set of data. So if I'm looking at my data over here, if I want to look at there's a SQL query behind the scenes over here that's generating the data for that particular visualization. Okay, but the users can access stuff through here. Interestingly, this star over here is their assistant that does the work for me if I need to change anything within there. So if I want to change any of the attributes, different types of visualizations, users have access to be able to change that themselves in real time.
How smart is that thing? Is it just like working off a predetermined set of criteria, or is there like an LLM and
It's got an LLM. This thing called Genie is an LLM, but I haven't really set it up behind the scenes. So I just want to show you a couple of things over here. So I showed you the catalog, which is where the data is stored. I can ingest any data that I want. So if I want to add any data to that, I can add or upload data. It lets me specify a range of different sources for my data over there. Before though, I had imported a CSV just by adding it in, and that CSV got written into workspace. Left click. Don't know where it wrote it. Dashboards. So that's in my catalog over here. So I imported a CSV, the MotoGP All Riders, which I downloaded from Kaggle. I thought I'd do something smart with it to show you guys, but I didn't get very far. Queries, dashboards. One thing that's interesting I wanted to show you was this data engineering side of thing over here. So this is where we define pipelines that let us go, right, I'm pulling in data from this source. I'm going to do some transformation on it. I'm going to write it into this table. Those are built within these data pipelines, which are very similar. If you've used SQL Server, it's similar to DTS. What's it called? They've got an ETL tool as part of that also. I'm going to do something brave and go create pipeline. Actually, there was a sample pipeline there. Let's do that. We'll create a sample pipeline. That is going to need a bit more work, really. I'm going to just do that on the fly. There's links into machine learning and LLMs down at the bottom. This is kind of a nod to the fact that a lot of people doing work on these are using machine learning, and the platform has these things built into there. So within the playground itself, I can add my own tools. I can do summarization, evaluation, and all sorts of other things. Again, haven't had time to play with those, but it's a 14-day trial if anyone wants to have a play with those. The one thing I did want to show is the going back in time idea. So if I go to my notebook over here, I've got a little notebook. So it uses the concept of notebooks, similar to other platforms where we're creating things that do stuff one after the other. An example over here, this is running a SQL statement. Behind the scenes, when you run a SQL statement, it actually converts it into PySpark to actually run. If I'm writing stuff straight in Python over here, again, everything is run as this PySpark jobs. I can drill into these jobs themselves to see what they're doing, what stages it has, what storage, and everything. I want to look under the covers how a particular statement is being executed, which may help optimization at a later phase. I did want to show you, this was my notebook where I was playing with that MotoGP riders over there. So I've pulled this into, so this is using PySpark to read that particular table and then showing what the schema looks like over there. And then converting it into a pandas data frame, which it can do natively over there. This is just showing you the type of data that we have over there. One thing I wanted to show, see at the front over here, I've got a rider called Rossi Valentino. Over here, the first statement, I'm describing the history of that particular table. And there's one entry, which was my creating that table. And then I run a statement that deletes where name is like Rossi. And if you look at the history over there after that, you can see the actual deletion happening on that table. But if I go to SQL and I select star from all riders, I'm going to run that. Rossi is there. I'm just going to go back and delete Rossi. Hang on a sec. Where is it? So let's run this again. And if I look at my data, Rossi's gone from the database.
I was expecting to
But-
still be there.
But if I restore the database, if I can do a select as of a particular version, or I can restore that particular version. So
Without restoring it.
sorry,
Without restoring
without restoring it, I will go back to ChatGPT when I looked up how to do this. So yeah, so if I select star as of a particular version, it'll pick up the data for me as of 5.
What would be nice is if you could put a time range into that.
You can instead of having versions, you can have time as well as of a certain time. Yeah.
So I do as of 0. No. So I didn't know what that is, so I'm going to click on diagnose error. So it's LLM comes in to give me a hand over there. To fix the syntax, you need the correct syntax as of, version as of, sorry. Version as of 0. Still don't like it. What am I doing wrong? So that's as of 0. But if I take off the version thing, I'll get the real one. Without the Rossi. So in a way, it represents almost like a time machine where I can go to a particular point in time.
Yeah, especially mix in those queries when you're doing aggregates as well, then it gets really useful. If you got data which is just mutating under your feet,
Yeah.
you know.
Again, it depends on the use case you have, right? But having the tools available to do this. As I said, the lovely thing about Databricks is also it's got this metadata called Unity Catalog that sits around that understands all the data, understands all the users, and manages the permissions of the users for a particular data set. So certain users could see certain columns and not others, for example, or can see certain rows or not others. So you can have a rule-based kind of access against your data, which from a governance point of view and a legal point of view is.
It's compulsory. You need to establish a rule-based access for every member of staff.
Okay, so that was me. That was a very quick run through of history of data lakes and a bit of Databricks. Hopefully this has sparked your interest to go off and do a bit of this. I'm not sure what the pricing is like around this, but the trial means that you can use it for 14 days, and if you find it useful, then obviously.
Cool. Is it 14 days for every separate instance that you create?
I think so.
Okay, so we can keep playing as long as you don't want your data there forever.
Yeah, but obviously if you're going to start using it.
Of course, no, yeah. Just because sometimes I start one of these trials and then I run out of time to play with it, and I want to play with it again later.
Yeah, no, it was when I came to creating the workspace in Azure.
Oh, cool.
I can either choose a premium one or choose a testing one.
Fabulous.
So it's not account level, it's workspace level.
It's workspace level.
Yeah, nice.
Interestingly, Databricks is a separate company to Azure. You can run Databricks on AWS. You can run Databricks on GCP. They're completely standalone. There were 3 or 4 university students who came up with this. I think it was their thesis, spun up a company, and now they're worth billions. Sorry? But it's all very innovative because I made I kind of, as I said, I did a bit of data lakey stuff in the Hadoop days and then came back to this and I was blown away. One of the things that's really, really nice about this is that if you're running a query, you can look at the provenance of your data, the lineage of your data, and it can go, right, this report run on this date came from these data sources that were extracted on this date and had this process run on them on this date. So you can show the whole trail of how that raw data changed through the whole infrastructure. So if a regulator comes around and goes, how did you come up with that figure? You can go, there you go. I talk about regulator because I talk about regulator because a lot of finance companies use Excel to do this and email Excel sheets to each other. So yeah.